but surprisingly, the hardest was semi-structured data. That is data that should be structured, but is unreliable, undocumented, hard to work with. And so really what we did was we tried building models. Mostly we failed because we never had enough data to converge it into something that made sense. We were spending, I want to say, starting Series C, we were spending close to $4-5 million a year just in integrations, which is no small budget for a company that size. So I was pretty much determined to make this, to fix this problem once and for all.
Hey buddy, welcome back to another episode of How AI is Built. Today we have a very special guest. Antonio Bustamante is a serial entrepreneur previously building Kite and Silo and is now working to fix bad data. He is building BAM, the data tool to transform any data into the schema your AI and software actually needs.
BAM fixes a problem that I've struggled with my entire career that I see other companies struggling with, which is data transformation. And so BAM focuses on being that systems interoperability layer so that systems that couldn't communicate before can now communicate things to an AI layer in between. And so we work with a lot of companies that are building B2B software in complex spaces, like supply chain, logistics, healthcare, insurance, where just by virtue of being in that industry, they need to deal with a lot of unstructured and structured data. And we act as a proxy. So we basically take in anything you send us, we transform it exactly into your internal data schema so that you don't have to parse, process, transform, anything of that sort.
Yeah, and that's like what we are already seeing a little bit in LLMs as well, where the focus is more and more on giving out semi-structured output as in JSONs. So we can use LLMs as well as part of a pipeline where the data flows through from beginning to end.
Exactly.
And can you give us some more context? So where did BAM actually get started? So what was the problem you really said, hey, I have to solve this? Do you have like a story behind that, why you went into
absolutely.
this space?
Boy, I have a story. I have many stories. Well, so basically when I was building Silo, because we were building in the food supply chain, mostly untouched by technology for many, many years, we had to deal with a lot of unstructured data, but surprisingly, the hardest was semi-structured data. That is data that should be structured, but is unreliable, undocumented, hard to work with. And so really what we did was we tried building models. This is many, many years ago. Mostly we failed because we never had enough data to converge it into something that made sense. And the volatility of the data structures coming in was such that it was very indeterministic, basically. And so we tried building this ourselves many years ago. And then when LLMs became more mature, that's when we started experimenting. And I started experimenting with taking in these like unstructured or semi-structured inputs. Probably the funniest story that I have for you is that a lot of our customers were farms and food suppliers and food distributors. So they did have price sheets. We needed to transform these price sheets into something that made sense in our application. And unfortunately, it broke every single time someone messed with the formatting of the document. So there were peaks of, let's call it unreliability in our system holidays. And the main reason is because during the holidays, people would add little like pumpkins during Halloween, or they would change the text from black to orange. Or for 4th of July, they would put a little flag. And so that broke all sorts of things in our system. So it actually became a real problem. We had to actually ask our users, please do not add more pumpkins to your price sheet so that we can actually parse the text behind it. So that was a real pain. We were spending, I want to say, starting Series C, we were spending close to $4-5 million a year just in integrations, which is no small budget for a company that size. So I was pretty much determined to make this, to fix this problem once and for all.
Yeah, and that's already like many people are like unhappy with LLMs being like stochastic and sometimes struggling to produce the right output. But even
Yeah.
if you're working with something like OCR, you already see like how like little things in the formatting or like how even like additional information on the same sheet can throw the complete model out of balance.
Yes, and I think the approach cannot be just OCR or just LLMs. To be honest with you, out of our secret sauce, if we can call it, as a company, I would say LLMs are a 30% of it. A lot of it is very, very like thorough validation layers, great infrastructure, just ensuring reliability and connection to our user systems. And so, what we realized pretty early on is that we can use the best parts of the LLM, the stochastic parts of the LLM can be used in our favor, but we also have to work with it and build very fault tolerant systems that allows us to take the best of it, but leave the worst out of it. And so I think it's very interesting because the approach cannot be just LLMs. And I've seen a lot of people trying to do similar things where 100% of the application is purely just
Yeah.
LLM based, and it cannot work.
So for me, it's always like it's in the end garbage in, garbage out. So many people are focusing on like extending the context window on LLMs, and I always try to focus like improve the quality of the data you're feeding in the end, and your output quality will skyrocket. Can we
Yes.
double click maybe a little bit on that? So if we imagine like a document is coming in, like an invoice, you want to extract the data out of it. Like, what are the major components, how you're processing this specific document to extract the relevant information?
Yeah, so without getting into too many details, essentially we structure two types of we take in two types of input, right? As you've mentioned already, we take unstructured inputs and we take structured inputs. The only difference between those two is that anything that is unstructured, we structure it. So we have a couple of layers where we analyze the geometry of the document and we make sure that not only we understand the raw information behind the PDF, whether it's tables, most of the PDFs that we receive are tables or some sort of pseudo tabular information. So we have a few layers of, hey, let's take in not just the raw text, but the geometry underneath the document to understand what I would call co-location of information, right? Because at the end of the day, what we want is not necessarily the best OCR for a human being, and that's what's interesting. A lot of companies are trying to use TextTract and other systems to essentially just extract raw text and feed it directly to the LLM. The problem is that LLMs don't think like humans, right? And so what we are focused on is making sure that we have the best output for an LLM, making sure that the geometry is there, that the semantic co-location of every single aspect in the document is there. And then once we've gone past that, then is when the magic happens. I mean, if you can call it magic, where we have a few layers of infrastructure that ensure the reliability of the system. We are processing a few thousand documents per hour at this point. And so it needs to be up and running and fast and accurate, which is a lot of requirements from our users, but it makes sense. And then we obviously have a combination of LLMs to not just transform the data, but transform it in context with their existing data. And so really the approach is a little bit different depending on whether you have transformed or structured or unstructured inputs.
One thing you mentioned, which makes me really curious, is like the optimal data for LLMs. Like, what for you is the optimal data to feed into LLMs?
We've done a heavy amount of experimentation, and honestly, the interesting thing is that in the last 6 months, there's been a lot of papers published on what is the right structure for a document to be processed by an LLM, and it's not always simply the raw text of the document. Yeah. Unfortunately, and I honestly call this just semantic co-location, which means LLMs are highly sensitive to the context by which you provide them certain information. And so if you have a complex document, you need to just make sure that the LLM understands not just what each of the complex data pieces in that document mean, but also how they refer to how they exist within the entire context, right? So you were talking about context window before. To us, context window is not nearly as important as the let's call it the format of by which we feed it to the LLM. You can use a million token context window and feed an entire document to an LLM. I can guarantee you, if you don't semantically chunk it out before, you're not going to get the right results. And I think people are starting to find that out now. There are a couple of companies that have successfully done this, and I would say one of the ones that comes to mind first is Doc LLM. I believe that was a team from a bank. I can't recall which one exactly, but they published a paper pending actual open source code that can prove the paper itself, where they realized pretty early on, yes, we have to process tons of unstructured data. The approach of purely extracting text and feeding it to LLM may not be the best. Let's find out what that is. So we've done a heavy amount of experimentation to structure it the right way.
Yeah. So I know, for example, the guys from Porty who are building a router they are often parsing like HTML, and they are basically feeding in the parent tags as additional information in the beginning before the actual text. What I like to do is, what I'm often doing is, when I'm using web information, I'm parsing it into Markdown, because I recognize like it's often like Markdown is a really good format to feed into LLMs. Do you have like other specific examples, like how you're tweaking the documents and what like semantic information, how you call it, you add to the specific text if you chunk it out?
Yeah, we don't do a lot of HTML. The one example I can think of is, in the context of HTML, we do parse tons of emails. And most email today is HTML inevitably. Something that is very interesting, and web purists may not like it, rightfully so, is a lot of the HTML conflates the semantic with the purely aesthetic. And so if you strip down all of the HTML from text, you sometimes can run into the problem of stripping down semantics. And so a lot of what we've done when we process, for example, tables and emails, most transactional emails today are just HTML tables. And a lot of what we've done is identify what parts of the markup of the HTML are actual semantics versus which ones are purely aesthetic. And so we do actually use a combination of both deterministic algorithms, but also orchestration. A single LLM cannot do it all. So we do actually orchestrate a heavy amount on our end to basically chunk out semantically and structure everything coming in.
Great. And you already mentioned like reliability is a major issue. And this is especially in the data space, like schema evolution is an still unsolved problem. So basically, when the schema changes over time, like a new column is added or another column is removed, how do you handle that? So the system actually is forward but also backward compatible, because your user might still use an old version of the software, and you have to ensure that everything works. So how do you handle that basically automatically? And especially, like, how do you infer when a piece of information is actually missing from the document? Because that's where LLMs often really struggle and start to just hallucinate.
Yes, which is such an interesting thing. So I think with respect to schema evolution, we're actually one way to think about us as a pure function. We've started incredibly simple. Now the advantage of that is that we're tightly connected to our users' existing schemas. So for us, transforming whether the user would want to move into a different schema or not, we version everything. So our pipelines are versioned. The user has full awareness of what version of the pipeline they're working with. The other thing to note is that a lot of our users, and this is fascinating, and I think it's very deeply connected to the sort of schema evolution, which is that humans are notoriously bad at designing ontologies, and so when we started, we assumed even the largest enterprises would have no problem in articulating what they want at the end of our function. And it turns out that's not true. In fact, a lot of what we do today with our customers isn't just transforming data, but actually recommending the best output for that data given what they need. And so we're starting to go more into a realm where rather than fight against the current and fight against that schema evolution, we're becoming part of it. And so we actually now start suggesting sort of evolutions of that schema based on what we know already, because we want to be part of that process. So rather than try to accommodate to it, we just want to enable schema evolution to the point where really what you want to do as an application engineer, let's call it, is to simply end up with a schema that is both not too verbose, but at the same time captures everything you need to enable your business logic, past, present, and future, which is very hard actually, right? Because hindsight is 2020. But we're slowly getting there. I feel like it's a very interesting sort of field that very few people are actually working on. With respect to your second question, which is great, now you have the schema. You can actually now evolve your schema with your needs, and we understand the business needs of our customers. How do we know when something isn't there, right? And I think what we do best is not just the transformation, but we do have a lot of validation, and that validation isn't purely static validation of the format, the schema, making sure everything is sent to you in a type-safe manner. It's also a lot of semantic validation. So something that we're starting to experiment with our customers with is by being connected directly to their existing data, we can actually do a heavy amount of semantic validation so that everything coming out isn't just shaped the way you need it to, but it also has all the right information. Happy to report, and knock on wood, we've never actually had issues with hallucinations on our LLMs for a couple of reasons. One, we're very narrow in scope. And that was actually something that we were very interested from the very beginning, right? So LLMs have, as you've seen already, multiple applications on the generative space. We're very narrow, and I call it a very sober application of LLMs. We're purely transformed data. And so the advantage of that is, unless something goes really, really wrong with the input, or even when you're asking for something, a typical hallucination from LLMs is asking something that isn't even there to begin with. We actually do a heavy amount of validation. And so by default, if we can't find something that you're really asking for, we always err on the side of actually returning something that says, this is not here specifically. And so rather than try to make it up on the spot, which is something that LLMs tend to do. So there needs to be almost, let's call it I know it's kind of interesting because from an LLM perspective, a lot of these LLMs have been built in an adversarial way from an interior algorithm perspective, but also very adversarial from the outside of the LLM to make sure that anything coming out is double checked, triple checked, not just semantically, but in shape, right?
Yeah, it all reminds me so much of like Bill Inman's writing about like the data warehouse and textual ETL, like what he calls the textual warehouse, where he's basically extracting the data from text. And he's also building heavily upon taxonomies. The biggest issue is like there are so few people actually studying information retrieval, information architectures, which is more in the like library sciences in the end. So how do you support your customers building and like thinking through taxonomies and ontologies?
Yeah, that's very interesting. We actually have, so all of our customers, we just have a direct line of communication with them. We have them all on Slack. We do actually a fair amount of collaboration when it comes to finding out the semantics behind the data. Something very interesting about us is that most of our customers are operating in very complex industries. And the difficulty in building in a complex industry is that there is a lot of folklore, vocabulary, and just domain knowledge expertise that is not applicable to, let's call it, generalized software. And so one example is, for the most part, if you're building a enterprise ERP like SAP or Oracle, you don't need to concern yourself with um, expertise in a particular domain. But if you are building ERPs, marketplaces, and platforms in, I mean, we have users in procurement, supply chain, and food, in lumber and metals, scrap yards. These are highly technical supply chains with a lot of vocabulary. So a lot of the inputs actually come in already assuming that this knowledge is implied in the system. And so we do a fair amount of collaboration to both understand their industry, but also make sure that our product is repeatable to more and more companies of either similar industries or adjacent ones. And so it's been really interesting. At the end of the day, is we're not, and this goes more into how to build repeatable software. But one of our obsessions is BEM needs to work for anyone that wants to use it. We don't do custom builds. We don't do custom patches. I've created companies before that unfortunately, we made the mistake of over-indexing on every single customer. And unfortunately, you can't find this repeatable pattern to build something that is truly added value. And so part of our obsession with them is how can we create orchestration of LLMs so that any knowledge or domain expertise of our customers is implied in the fabric itself of the product, as opposed to us having to like hard code that these acronyms from this industry mean this or that. So it's been very interesting. Definitely more an exercise on ontology designs and semantics than really anything stochastic or LLMs. Interesting thing is that a lot of people complain about the output of LLMs, but the reality of the situation is that most humans can't even articulate proper ontologies to begin with, and most companies struggle with this. I do anticipate as we grow as a company, we'll probably hire people that are just like ontology experts in designing semantics and designing ontologies, knowledge representation. I think is going to be a very, very big component of them.
I can send you a few podcasts I listen to because it's a big issue at the moment for me as well. I can send you a few podcasts which are really like on the taxonomy way, which are like a nice introduction because you have like often two different issues you're facing. For one, in taxonomies, it's always an open set problem. You never know, or you can be in the end sure you don't have all the different classes or the complete hierarchy you actually need.
Completely.
So it has to evolve over time. And for that, you always need to have like a fallback value, for example, in LLMs. And when you recognize like too many classes are coming into the fallback value, you have to analyze them to basically, with the domain experts, come up with new classes which can capture those elements. Or if they should be captured by another class, you have to basically go back and refine your algorithm so it can actually correctly classify them.
Completely agree. And not only that, but I think this goes back to, are we building fault-proof software or fault-tolerant software? And both my co-founder and I have had long philosophical conversations about this, but the world needs to go more into the realm of fault-tolerant software. The reality is that LLMs are stochastic functions. So you can't assume, not only you can't assume that there is a deterministic output on the other end, however much validation you do, but also there is a problem of most of the knowledge sets we're dealing with, just like you're saying, are not finite sets and they will never be. And so we're already building software assuming that it will have to forever learn something. There's always going to be the chance that it will run into something that it has never run before, either by virtue of new knowledge being integrated into the industry or we've also run into a heavy amount of people expressing industry knowledge in different ways other than the norm. That's a very interesting thing that we're actually dealing with at the moment.
Yeah, and also different specialization expressing the same way in a different like the same thing in a different way, or they are expressing basically a different thing in the same way. And these are all the complexities you have to capture also.
Exactly. So we're trying to be building very flexible taxonomies. This is a problem that started way, way before when I was building Silo. We were building in the food supply chain. We had a catalog. Part of our ambition was to homogenize the entire food catalog of Earth. And that was a crazy feat because we ran up against governments having their own taxonomies, most of them wrong. The industry having taxonomies that were semantically right, just poorly structured. And so it was fascinating. It was fascinating. And a lot of the, let's call it structurization problems that we had at Silo years ago were not so much structuring documents. It was just understanding what type of apple is this farmer talking about. And I guarantee you, a lot of farmers they're very good at marketing and branding. So they make up new names of apples. And those names sometimes are just other existing product categories that exist in the taxonomy. It's just virtually impossible at that moment to make an inference, right, on what type of apple are they talking about.
Yeah. So we already discussed it a little bit, like BAM fitting into the larger ecosystem. Where would you place BAM around like the other technologies, like the data lake we have often, like data lake houses, delta lakes, and actually like textual warehouses you have nowadays?
I mean, this question is great because I feel like when we fundraised last year, that was the question that every investor asks you, and some of them get it, some of them don't. So I would say we're not a data lake and we're not an ETL. ETLs are very good at, let's call it, field mapping transformation, and they're very good at data aggregation. We're not a data aggregator. Don't use us to just aggregate multiple sources of information into one. We're purely a transformation function. So a lot of our customers already embed us in their data pipeline with data lakes in it, with ETLs in it. Like we're not competing with ETLs or data lakes at all. We're purely a data transformation function. Now, interestingly, a lot of our customers have used us for, let's call it internal workflows, right? You generally don't you don't expose a data lake to your end users of your application. You expose them to a production application that is more suited to their needs, right? And while some of our customers, like I'm saying, can use BEM for RPA building and for internal workflows, where we add the most amount of value and where our customers are integrating us today is directly in product mission critical flows. I think of ourselves more as a layer upon which to build a product and product features than as like an internal workflow builder. There are companies far better suited for that. And in fact, something that we're starting to see is a lot of our customers come from companies that are known for building these RPA internal workflows, but they're complaining about how prescriptive they are and how strict they are. So what I tell our users is don't think about us as a document review system or even a RPA or internal workflow or a data lake. Think of ourselves as the building blocks to build your own. And so some of our customers are starting to get it, and they're starting to build their own document review workflows on top of BAM. Because we deal with the worst part, which is the pure transformation function.
Yeah. Great. So what tool would you love to see being built in the data or AI space on top or next to BAM that would complement it to make it like even more productive or performant for the end user?
That's a good question. I've thought a lot about this because we do a lot of dog fooding ourselves by building applications. So a lot of our dog fooding is just building new applications internally. So I see it as three layers of value. You can use us to process invoices. and structure them. Let's call it low value. Like I'm not actually, you can use us for that. I don't think we add a lot of value there. There are tons of competitors. I think we're simpler to use than most of our competitors, but I don't think that it's that such big of a deal. The next layer is interoperability between systems, and that's where we start adding a ton of value. So we're more focused on communicating to systems that otherwise they would not talk to each other than with document review, right? The document review has been done 100 times before. I'm not particularly interested in the field. I think a lot of our customers are building their own document review tools on top of us, but we're not focused on document review. We're focused on systems integrating with each other, right? So whereas a few years ago or a few months ago, to integrate with QuickBooks or with financial systems or with EDI or with Nacha, you had to use third-party integrators or, God forbid, build your own integration. We're starting to go more and more to a world where you're not going to need that. So I would say we're not even competing with integrators because we're building a very lateral technology. And in fact, integrators themselves could use our technology to sort of facilitate things for their customers. Something that I'm very interested in seeing someone build, and we're starting to build internally, is directly user-exposed interfaces built with BEM. And I think that a lot of the future of enterprise software is going to be based on that. And so I'll give you an example. And most of this flies under the radar because it's not sexy software and no one cares to build on it, or very few people care to build on it. You have ERPs today that are worth billions and billions of dollars, where users every day struggle inputting the most basic things into the software. And I dealt with this at Silo. I can't say that this is only a problem with legacy ERPs like Oracle and SAP. This is also a problem with new ERPs. The fact of the matter is there is an inherent complexity in the information that you have to input. So let's say that I want to build an order in QuickBooks and fill in an invoice. I need to search one by one every single product. I need to find the right pricing. I need to find the customer. There's a heavy amount of fuzzy matching and searching to find all these customers. Now, I want to see more people build experiences with BEM where you assist users in participating in complex enterprise flows. And so we're starting to see a few users that they're getting this, which is BEM isn't just a layer of interoperability between systems. Sometimes those systems are human. And just because I call it a system does not mean that it has an API and outputs JSON. Sometimes humans just output text and output speech and output things that they think are structured but are not, or are not computer readable. So that's kind of the world we're living in. I would call it the revolution that USB brought to peripherals connected to computers is the revolution that we're trying to build when connecting between systems. I feel like we're back in the 90s where you had to download a driver every time you wanted to use a little new thing. You have your parallel port. I want that gone. I want systems to just seamlessly be able to talk to each other and use our system as like a sort of serial bus, if we can call it, that is universally understanding of context.
So what's next for you guys?
Well, we're busy. We're super busy, and so we're going live with for the first time in production with a few users this month, which is a milestone that we were looking forward to. We were talking about reliability before. That's been top of mind for us because the needs of our customers are such that we're receiving tens to hundreds of thousands of data points every single day. Now it's going to grow into the millions. It needs to be accurate. So that's the other thing we're working on. We're always going to be working on accuracy. Unanimously is what users ask us. I always ask our users, we talk to them every single day, what do you guys want? And they're like, reliability and accuracy. It needs to be fast, it needs to be available, and it needs to be perfect. And so that's been our two optimization functions. And I think they will forever be. More sort of going into the year, we want to have a general availability product that teams can simply sign up, onboard in 5 minutes, and start using. And so we're obsessed with time to value. I feel like there is a misunderstanding in the industry that just because a product is technical, it should take an army of engineers and 2 months of work to integrate with. And I've been a CTO before, and I've been on the buying side of this. The easier, the better. And so our goal, our milestone is basically 5-minute onboarding max, and then you're ready to go. And so we're focused on building a sort of a GA version of the product that people can just up and run and just test it. There's no more transparent way of releasing a product than just throwing it out there and see what people say. So we're definitely very excited.
Great. So how can people follow you, stay updated with them, or get a notification when they actually can start to use the tool?
We're at BAM.ai. Visit us, check us out. We're revamping our website to sort of showcase the biggest use cases that we've seen now. But honestly, there's a contact form there. Check us out. And we're also on LinkedIn and Twitter. Something to note is we're building a community. And so something that I think is very important to note is all of our customers share one thing. They share many things, but there's one thing that can basically describe our customers, and is software companies building in real life scenarios that are highly complex. And so a lot of our customers are building ERPs, marketplaces, accounting systems for industries that people would never, decide to work on. And so we're building a community of engineers building this, because I feel like these types of challenges that we're fixing are the challenges that they're running into the most. Our vision at the end of the day is I want engineers to focus on building the top 20% of things for their team so that we can deal with the bottom 80%. So yeah, they can check us out on LinkedIn. They can check us out on the socials, like that. But we're also at BAM.ai with a few use cases, demos, and whatnot. So yeah.